And wrapping up, it is a pleasure to be on the same stage with a young man who has done exploits in our community with science, and that's none other than Dave Minshew. So thank you, Dave, for everything you do. God bless you.
Now I'd like to introduce Modesto Junior College President Brian Sanders, who's going to introduce tonight's speaker.
Use one of these if I can. Yeah, there we go. Nope, it wasn't. Almost, kind of, sort of. He's going to find it. Got it? All right. So yeah, my name is Brian Sanders. I'm get to be the president here. It's a new gig for me. I just got started 19 days ago. So it's a neat feeling. I wanted to start tonight by asking the members of the MAPS committee to stand. Because, here's an event. You all came to this event. These folks put this on. They put in all of this time and energy, and they've been doing it for many, many years. Give them a round of applause, please. There's another group of faculty members on campus who have started a new series, and they're having some success. They're getting people to come in from the public. In fact, Mayor Zwallen was one of the speakers last year, and they shared with me, like, well, it was a lot of work, and I don't know if we can keep it going. And I looked at them and said, you need to just keep it up. It takes being respectfully stubborn. It takes asking. It takes just pushing on, whatever your passion is. Programs like this run because of faculty champions and other champions and folks in the community that are championing these causes. But when you find something that you're passionate about, champion it, stick to it. You're going to be in those positions of making it happen. Leaders are going to change, but we're going to come by and we're going to support the faculty champions in getting things done. I wanted to ask my mathematician buddies to stand up. Because today is not just MAPS, it's MAPM, Modesto Area Partners in Mathematics, and I've got a couple. What are you doing? This person over here, I saw one over here. These are some of the math professors at our college, and they're certainly part of our science community, but we are especially excited tonight. And I say they're my peeps because I started here as a part-time math professor, math instructor way back in 1994, and I got to be a full-time tenured instructor. And in that role, 20 plus years ago, I came to a MAPS presentation with Dr. Art Benjamin. And I was blown away, and I thought to myself afterwards, I can't do that. I don't have that. But I challenged myself to try some things, to try some more mental mathematics, and to get away from doing everything on a calculator, and it was worth it. And so that's the challenge I have for all of you today. You may not be able to replicate the magic, but figure out what you can do. And I took those same techniques when I was a math teacher into my elementary school math classes, my math for elementary teachers. And I shared, and I shared some of those techniques with these young teachers. One of whom I heard from recently, this tells you how long ago it was. She was my student at MJC, and then she finished her bachelor's degree, and then she got her teaching credential, then she got a teaching job, and she taught math, and she used some of those techniques in her classroom, and then she became a principal, and then a principal of another school, and then a principal of another school, and she sent me a really nice thank you note the other day, and congratulations on being my new role, and I congratulated her on her new role. But think back on all the people that were affected by my being at Dr. Benjamin's talk and inspired in the clever, fun, exciting things about mathematics that we're going to learn about tonight. So, with all of that introduction, I shall now introduce Dr. Arthur Benjamin. He, for 35 years, has been a professor at Harvey Mudd College. Anybody know where Harvey Mudd is? Raise your hand, there's a few. All right, good place to go. He performed his mixture of math and magic all over the world. He's performed 3 TED Talks with over 50 million views. The New York Times best-selling author, and he's a Reader's Digest calls him America's Best Math Whiz. Please welcome to the stage, the math magician, Dr. Arthur Benjamin.
Thank you, Adam. Wow. So great to see over 100 people doing math on a Friday night. I'm in line. Good evening, ladies and gentlemen. My name is Art Benjamin, and I am a mathematician. What that means is I combine my loves of math and magic to do something I call mathemagics. But before I get started with anything too mathematical, I thought I'd begin with a magic trick. It has nothing to do with math, really. It's just a really cool trick. But for this, I'll need a volunteer to assist me. Someone here I do not know. Let's see, I do not know. Okay, you in the gray t-shirt. What's your name? Hunter. Let's give Hunter a nice round of applause. Come on up here, Hunter. Hunter, if you would stand right there. All right, or one right there, that's fine too. Now, Hunter, before I begin, I have an important question to ask. Have we ever met before? No, you seem proud of that fact. But that's good, because Hunter, I'm going to show you and everyone here a card trick that has never been seen before. Never been seen before because no one can see the cards. Hunter, if you would, pick a card, any card at all from the deck. Great. Look at the card, show it to everyone, but do not let me see it. That's important. All right. I will shuffle the rest of the cards so you see they're not in any special order. Hunter, I'd like you to place the card back inside the deck, but just to make it interesting, turn the card upside down first. Upside down. Oh man, you shoved it right in there. Great. Notice all the cards are face up, except for Hunter's, which is face down. Now watch carefully, as this took me years of practice. Watch, watch, watch. As I make the deck of cards disappear from my hands, reappear inside of this box. A box which only moments ago, Hunter, was empty. Trust me. Now I realize, Hunter, what you were doing a moment ago was just a figment of your imagination. But what was the card, for that brief second at least, that you imagined that you selected? Hunter, what card did you imagine? An ace. An ace of spade, heart, diamond, or club. Which one? Ace of spades. A pretty frequently thought of card, but you know what? I knew you would say that because you'll notice in this deck that one card, and only one card, has been turned upside down. Would you be so kind as to show everyone the upside down card, the ace of spades, and let's give Hunter a nice round of applause. Thank you, Hunter. Very well. Very good. Thank you. While you're trying to figure that one out, I have another question for the audience. By any chance, did anyone happen to bring with them this evening a calculator? If you have one, perhaps on your phone, and if you're comfortable using it, raise your hand. I need a few people to help me out with their calculators. And let's see, I see one volunteer here. There's one. And who else would like to help out here? Okay, two. And how about three? And one more volunteer, it'll be fun. Okay, four. With the four of you, bring out your calculators, join me up here on stage. Let's give these volunteers a nice round of applause. Come on up. Fantastic. Whoops, I'm getting a little fast. That's okay. The more the merrier. One more round of applause for our brave volunteers. Right this way. Right this way. Thank you, thank you, thank you. Fantastic. Now, since I have not had a chance to work with these calculators, I need to make sure they are all working properly. Would somebody get us started by giving us a two-digit number, please? How about a two-digit number?
23.
23. And another two-digit number, sir. 69. Multiply 23 times 69. Make sure you get 1,587 exactly, or the calculators are not working. Are all your calculators working? 1587, 1587. Give them a round of applause. Now, I notice that took some of us a little time to get the answer, and that's okay. I'll give you a shortcut for multiplying even faster. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be what? 25. Good. 6 squared would be 36. 73 squared would be something bigger. Right. Now, most of your calculators have little shortcuts for squaring. Like on this one, I know if you take a number like 5, press times, and then equals, it gives you the square, just like magic. And it might not work on all your calculators, but if you have a shortcut, feel free to use it. What I'm going to try and do now is to square in my head 5 2-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll ask is 5 people here, how about in the first row, how about 1, 2, 3, 4, 5, each yell out a 2-digit number, and if you would square the first, the second, the third, the fourth, and the 5th one, I will try and race you to the answer. So, quickly, a 2-digit number, sir. What, don't say again? 52 squared. Okay, next. 84, next. 48, next. 35, next. 19, and what did you get? 2,704, 7,056, 2,304, 1,225, and finally 361. Give them a round of applause. Well done. Let me try to take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone from the audience call out a 3-digit number, not yet. Anyone on our panel, verify the answer. If I get the answer right, either give me a thumbs up or show your calculator. If I make a mistake, let me know and I'll try and fix it. Okay, a 3-digit number, please.
367.
367 squared is 134,689. Yes, good. Another 3-digit number. Go ahead. 498 is 248,004. 248004. Yes, good. How about another 3-digit number? Yes, sir. 102 is 10,404. 10404. Great. How about another 3-digit number, sir?
999.
Oh, everyone gives me that. So 999 is 998,001. Yes, good. How about another 3-digit number? Go ahead. 429 is 184,041. Yes, good. How about one more 3-digit number? 989 is 978,121. Thank you very much. Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, I'm not going to beat you to the answer on this one, but I will try to get the answer right. To make this a little bit more random, how about we take this second row, if I can get the first 4 of you to call out a single digit between 0 and 9, that will be the 4-digit number that we'll use. 3. 4. 7. This will take me a little bit of time, so bear with me. 12 million. Wait, I'll start all over again. 11 million. Oh man, look at this. How about 881,809? Good. Thank you very much. Now, I would attempt to square a 5-digit number, and I can, but we'll have to save that for later. In the meanwhile, let me conclude the first part of my show by trying something a little trickier. Let's take the 4-digit number that you gave me here at random, 3447. Would you each enter that number on your calculator? 3447. And instead of squaring it this time, I'd like you to take that number and multiply it by any 3-digit number that you'd like. But don't tell me what you're multiplying by. Just multiply it by any random 3-digit number. So you should have as an answer either a 6-digit or probably a 7-digit number. How many digits are in your answer there? 6 or 7? 7. 7. Wow, okay, it's our lucky night, all 7s. Is there any possible way that I could know what 7-digit numbers they have? Say no. Good. And I shall attempt the impossible, or at least the improbable. What I'd like each of you to do is to call out for me any 6 of your 7 digits, any 6 of them, in any order you'd like. 1 digit at a time. I shall try and determine the digit you've left out. So starting with your 7-digit number, call out any 6 of them, please, and I'll repeat them for the audience. 607-435. Did you leave out the number 2? Yes, good. That's 1. You've got a 7-digit number. Call out any 6 of yours, loud and clear.
19630.
I only heard 5. Okay. 196-302. Did you leave out the number 6? Fantastic. That's 2. You've got a 7-digit number. Any 6 of yours in any order.
606322.
I heard a 606322. Did you leave out the number 8? Great. Okay. How about another 6 digits in any order you'd like?
544681.
Did you leave out the number 8? Good. The odds of getting all 5 of these right by pure guessing would be 1 in 100,000, 10 to the 5th power. Okay, any 6 of yours, and really scramble them up this time.
38524.
I heard 5 digits. 38524. Ooh, this is tricky. Do me a favor, if you would, concentrate on the digit you left out. Doesn't do any good, of course, it just looks dramatic. And yet, I seem to be getting a lot of nothing. You didn't leave out a 0, did you? No? Yes, oh, that's why I was getting a lot of nothing. Let's give all 5 of these people a nice round of applause. Thank you very much. Thank you. Well, for my next number, I'd like to present something that we mathematicians refer to as magic squares. If you've never seen a magic square before, I'll prepare to be amazed. I've done such an extensive study on magic squares, and I'd like to create one for all of you right before your very eyes. But for this, I'll need another assistant, someone here I do not know, and I do not know you. What's your name? Yeah. Let's give Lila a nice round of applause. Come up here, Lila. Lila steps right over there. Fantastic. Let's give Lila another round of applause. I really appreciate that. Hey, Lila, please stand right there. Now I have to ask you a question. Is it L-I-L-A?
It's L-Y-L.
L-Y-L-A. Spelling was not my best subject. Lila, let me ask you another question, and if it's too personal, I can change the question. Lila, are you willing to share with us your birthday, including the year?
Yeah.
Yes, great. Okay, so Lila, stand right there and give us the birthday. What is your birthday? 6/17/2012. Now, Lila, if we were to add the numbers in your birthday together, let's see what we get. We have 6 plus 17 is 23, plus 20 is 43, plus 12 is 55, so 55 becomes your magic number. It's a favorite number of mine, too. It happens to be a Fibonacci number. More about that later. All right, so Lila, what I'm going to try and do is to fill out this box in such a way as to get these magic numbers to add up to your magic number. This will take me a couple of seconds, so bear with me here. I think that works. Lila, would you choose for us any row? Row number 2, 3, or 4, which would you like? 4. All right, class, together. 17 plus 4 is 21. Plus 14 is 35. Plus 20 is 55. The others were 6, 23, 43, 55, 19, 32, 37, 55, 13, 34, 50, 55. Would you choose a column, Lila? 1, 2, 3, or 4? 3. All right, class. 20 plus 5 is 25. Plus 16 is 41. Plus 14 is 55. The others were 6, 25, 38, 55, 17, 30, 51, 55, 12, 30, 35, 55. How about that? I'm not through with you. I decided since this was your magic square, based on your birthday, at no extra charge, I would give you these diagonals as well. Check it out here. 17 plus 21 is 38, plus 5 is 43, plus 12 is 55, 6, 19, 35, 55. But I didn't stop there either. I decided since this was for Lila, wouldn't it be great if we could get these 4 in the center to add up as well? Check it out here. 21 plus 13 is 34, plus 5 is 39, plus 16 is 55. But did I stop there? No. Did I stop there? No. Lila, you may have noticed I put a little extra attention in that corner. I did that so I could get these 4 squares. 6 plus 17 is 23, plus 13 is 36, plus 19 is 55 to add up. And I figured, heck, as long as we got that group of 4, let's have a party. We may as well get this group of 4, 20, 32, 50, 55, 13, 34, 38, 55, 16, 21, 41, 55. But did I stop there? No! I said Lila wouldn't be happy unless we got this group of 4, 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 this group of 4. And I have to apologize, Lila, I was not able to get this group of 4 nor that group of 4 to add up, but I had to do it that way if I was going to get these 4 in the corners. I knew that would be important to you. 6, 18, 38, 55. But wait, here's the cool part. Lila, not only do the 4 numbers in the corners add to 55, if you look at them closely, you'll see we have 6, 17, 2012. I thought you'd like that. So please keep this as a souvenir from me, and let's all give Lila a nice round of applause. Thank you, Lila. Thank you. Awesome. Hey, speaking of birthdays, by any chance, does anyone here happen to know the day of the week that they were actually born on? If you think you know your birthday and you're willing to share it, raise your hand. I started with you. What year, if I may, Justy?
1965.
65. And what month?
August.
August what?
27.
27. Was that a Friday? Yes, good. Somebody else. How about yours? Yes, what year? 86, did you say? And what month? March what? 30th. Was that a Sunday? How about right behind you? What year? Yeah.
1964.
Oh, 64. And the month?
May.
May what?
First.
Was that a Friday? Fantastic. Okay, towards the back. Yes. What year? What? I'm going to that person right there with the letters on the t-shirt. Got it? One more time.
March 16th, 2023.
Well, wait, I was going for that person. Yeah, you. Well, wait, say the year again.
1984.
84. And the month? June what?
25th.
25th, 25 was that? Was that a Monday?
Yes.
Fantastic. Thank you very much. By the way, anyone else who wants to find out their day of week, see me after the show. I'll be hanging out in the lobby. I'll be answering questions, autographing stuff if you want. And I'll be more than happy to tell you, sincerely. Now, folks, if I were performing for a different sort of audience, I might follow this up with other feats of magic and mind. But for an audience such as this one, I actually prefer to break the magician's rule and explain to you most of what you've seen me do up here and more. In fact, I'd like to conduct the rest of this program, the next 25, 30 minutes or so, very informally, So feel free at any time to interrupt me with questions about anything at all. It's more interesting that way. In fact, I've got hours and hours of stuff to share with you, but only another 30 minutes or so to be on the stage. So let me take your questions now. Who would like the first question? Don't be shy. It's not math class. What would you like to know? Yes, sir. Yes, please.
I'm sure you practiced at home or whatever. I'm sure you practiced at home. What's the largest square you can do?
The largest number that I can square, is that what you're asking? Or,
Yeah, I'm not saying like, I'm not going to...
reliably.
Yeah.
The largest I've ever really been able to do consistently, and this was back in my college days as I was really putting energy into these skills, was multiplying two different 6-digit numbers. Right? And that would take me over 5 minutes to do, and I had about a 50% accuracy on that. What I'll do for you tonight is a 5-digit square, which will take much less time, and I'll have a better chance of getting it. But yeah, no, it's a skill. It's something that you can practice. You have a follow-up question?
Yes. How come you stopped at squares? How come not keep going?
Oh, well, the squaring, well, I'll take your question as, the question was, well, why do squaring so much? I mean, I do other kinds of multiplication, but squaring is especially fast, and I'll show you the method that I use for squaring numbers. Starting with 2-digit numbers, and if you're interested, I can show you how to push it up to 3 digits or higher. Give us a small 2-digit number as our first example. Go ahead.
96.
96. That's not a small 2-digit number. Maybe in your family, but I'll tell you what, I'll save that one for later. Give us a smaller one first, in the under 30, just for the first example.
16.
16, great. Now 16 squared is 256, and I just know that because I've been squaring numbers for a very long time. But let me show you the method that I use for doing this. Now 16 is not a bad number to multiply, but what number close to 16 is even easier? Well, 15 is not bad, but 20 is even better because 20 ends in 0, and I like zeros. Zeros help the mental math go down easier. So I'm going to go up 4 to 20, and to balance it, I have to go down 4 to 12. All right? So the first part of my calculation is I do 20 times 12. All right, now 20 times 12, well, that's 2 times 12 with my friendly 0 attached. If you take 2 times 12, you get what? 24. So 20 times 12 is 240. Almost done. All we have to add to this is the square of the number we went up and down. We went up and down 4. 4 squared is 16, and there's your answer, 256. Here, let's do a couple more examples. I want to make sure you get really good at this. Let's try, give us another 2-digit number. Go ahead. 28. So this time, we'll go up 2 to 30. Thus, we go down to what number? 26. If I go up 2, I have to go down 2. Now, 30 times 26. That might look hard, but it's not too bad. If there's only one thing you remember about the mental math that I'm going to show you tonight, it should be this. I do all of my calculating from left to right. And that's the opposite of how you might do it on paper. On paper, we do it from right to left. We do the ones digit, the tens, the hundreds, the thousands, and so on. But that's backwards. You read the numbers left to right, you pronounce the numbers left to right, and when you do the math in your head, you also want to do it left to right. On paper, it's a different story. Go ahead and do it right to left. But when you're doing the math in your head, we do it left to right. So let's do 3 times 26 from left to right. 3 times 20 is 60. 3 times 6 is 18. 60 plus 18 from left to right is 78. With the friendly 0 is 780. Almost done. All we have to add to this, some people math just makes them cry. I know, but we're almost there. We have 780, Add to that the square of 2, which is 4, and that's your answer, 784. Okay, now it's your turn, and we're going to do the problem that you asked at the beginning. It sounds hard, but it's actually pretty easy if you do it this way. So, okay, and I'm going to give you all a lot of time to do this problem in your head. You're all going to get 10 seconds, okay? I know it's a long time, but I think you can do it, all right? When you think you have the answer, raise your hand. I want you to try to square the number 96. Don't shout out the answer, just try and think, do it in your head. Think of what you'll go up to. Then think of what you'll go down to. Multiply them together. And then you're going to add something. All right, so take a few more seconds. If you think you've got the answer, raise your hand. All right. All right. What do you have? What did you get as your answer? No, what did you get as your answer? 9,216. Give her a round of applause. Well done. And what did you do, I hope? You went up 4 to 100, down 4 to 92. 92 times 100 is 9,200 plus the square of 4, which is 16, and you get exactly 9,216. Another round of applause, especially if you got it right. Well done. Now, I have to confess, I've been squaring 2-digit numbers for more than half my life at this point. So most of the 2-digit squares have unintentionally become memorized to me. But for 3-digit squares and higher, even though I've done a lot of them, I don't have almost any of the answers memorized. I really do have to calculate it. Let me do one 3-digit number for you. And I don't think you're ready to do this yourself. But once you get really good at 2-digit numbers, you can take the next step. Give us a 3-digit number, please.
121.
121. Oh, that's a really good one. The answer, by the way, is 14,641. And let's see how. I mean, it actually isn't so bad. Now, when I square a 2-digit number, I go up or down to the nearest multiple of 10. When I square a 3-digit number, I go up or down to the nearest 100. So for the number 121, I'm going to go down 21 to 100, up 21 to 142. Now before we go further, let's quickly do 21 squared on this board, right? We go down 1 to 20, up 1 to 22. 20 times 22 is 440, plus the square of 1 is 441. Why did I do that? Because when I square 121, I go down 21 to 100, up 21 to 142, multiply those together to get what? 14,200, and we add to that the square of 21, which is staring us in the face. Right? That's 441. And when you add them from left to right, you get, as promised, 14,641. Thank you very much. Now, I should tell you, and I'm obligated to tell you because we have a lot of math teachers or former math teachers in the audience, including our newly elected president here. So I have to just to fulfill my own sense of righteousness, I have to show you why this works. I mean, I've shown you how to do it, but let's briefly see why it works. And for any of you who've taken an algebra class, here's what's going on. If I want to square a number A, then the process that I'm using is I say take that number A and go up some distance to some nice number. And then take A and go down the same distance, multiply them together, and what do we add? If I do A plus D times A minus D, I'm then adding D squared. And is this going to work? Well, if you remember your algebra, A plus D times A minus D, anyone, is A squared minus D squared. And when you add this d squared, the d's go away, and you're left with a squared. Let's hear it for algebra, right? All right. So this allows, I don't think of the algebra when I'm doing my mental math, but it gives me the confidence to know that this process is always going to work, whether I'm squaring a 2-digit number, a 3-digit number, or higher. That's one of the reasons I like squaring so much. So, great question. Other questions? What else would you like to know? Yes, Lila, what's your question? Lila, say that again.
Have you ever met Bill Nye the Science Guy?
Have you ever had Bill Nye the Science Guy? Well, there he is, right in the middle. Either I met him or I snuck up behind him and went, so take my picture. Now, we've actually done a couple of, we've been on the same stage a few times before. Really nice guy, really smart guy. I'm a huge fan of Bill Nye the Science Guy, for sure. Other questions? What else would you like to know? Yes, sir?
Do you have children that have the same gifting?
Do I have children with the same gift? I have 2 daughters. I should say, my wife also has training in mathematics, and everyone was afraid that we were going to give our kids mathematical names, like if it was a boy, Adam, if it was a girl, Subtractum, something like that. Luckily, we didn't. Laurel and Ariel are doing just fine. Both of them were good at math, and I would even go so far as to say they certainly weren't afraid of math. I mean, that's what we wanted to make sure. But I didn't want to turn them into miniature versions of me. I wanted them to find their passions. And that's what they've done. So my daughters are now 25 and 21. And one of them is studying to be a clinical psychologist. The other one has a passion for maker spaces, doing 3D printing and laser cutting and all kinds of button making and all kinds of creative stuff. So they have found their passion, which is what was most important to me. Thank you for asking that. Yes, what's your question?
How does the magic box work?
How did I do the magic square, she says. Magicians are not supposed to reveal their secrets, but you asked very nicely. Well, let me tell you why magicians don't reveal their secrets. It's because we've all made that mistake before. We've explained how a magic trick worked, and we never get the reaction we want. We want people to say, wow, that's clever, you're good, but you never do. I mean, how have you reacted most of the time that somebody explained a magic trick to you? It's like, oh, that's kind of dumb. I thought you were good, but I just wasn't paying attention. And it's true on almost every magic trick out there, including the magic square. But you asked nicely, so I will show you how we did it. But just remember how impressed you were before I gave you the explanation, okay? Is that a deal? Now, since you asked, I'll do your birthday, and I'll show everyone how it works. So, what is your birthday, please?
5/30/2011.
5/30/2011. So, 5/30/2011. For people born in the 1900s, like if you were 1998, I wouldn't put a 19 and a 98 because that 98 is too big. I would just put a 9 and an 8. But for everyone born in the 2000s, I put a 20 there, and that helps us a lot. Okay, so step 1, and it's the most important step, is you have to add these 4 numbers correctly. Because if you mess up here, there's nothing you can do. All right, so let's see. 30 plus 20 is 50, plus 11 is 61, plus 5 is 66. I write that number nice and big so the audience can see it, but so can I. I'm going to use that number a lot. Okay, now if you remember with Lila's magic square, the birthday is not just in the top row, it's also in the 4 corners, right? So what number is going to go here? 30, and that's the first number I write down. Now what number is going to go there? 20, but that's actually the last number I write down because I don't want people to see the pattern right away. Okay. Next, I always fill the magic square up in the same order. I begin by going up this diagonal, and the good news is for everyone born in the 2000s, the number that I put here is 21. In general, I'll take this number and add 1 to it, okay? So if you're in the 2000s, that's going to be the number 21. Now it becomes like the easiest Sudoku you've ever tried, because we know that these 4 numbers on the diagonal have to add up to 66. Right now I have 3 numbers on the diagonal. 30 plus 21 is 51, plus 11 is 62. So if these 3 numbers add up to 62, what has to go here to get to 66? 4. Oh, you got it. Okay, 4. And I put that right there. Now I have a new group of 4 to look at. These 4. If you remember with Lila's magic square, we get this group of 4 to add up. I've got 20 plus 11 plus 4 is 35. And if I want to get 66, this is going to have to be 31. In fact, it's always this number plus 1, but I don't memorize that. I just do the math. Okay, now I keep on going. This group of 4 adds up to, these 3 numbers add up to 54. So if I want 66, this is going to be a 12. Then I go to this group of 4, and this number here is going to be 19. And I don't even have to do any math on that, because if this is a 21, this is always a 19. So that saves me some time. Now, remember with Lila's magic square, I said we were not able to get this group of 4 or that group of 4 to add up. Don't even try. It'll mess up other things. That's the bad news. The good news is the way the algebra works, these 2 numbers are always the same, and those 2 numbers are always the same. So all I have to do is slide this 12 down here, and that's going to work. You can check out the first column. That's going to add up. Okay, finish up quickly. I go to the middle group. 21 plus 12 plus 4 is 37, makes this a 29. 30 plus 12 plus 21 is 63, that makes this a 3. 21 plus 29 plus 3 is 53, that makes this a 13. Your brain's getting tired from all the adding and subtracting, so I say the easiest part's for last. What number goes here? 4. I just slide it down. And what number goes there? From the very beginning, 20, and that's the secret of the magic square. Thank you very much. And what's your name? Kate, K-A-T-E. How about I write it as a K and an 8? Okay? So now this is for Kate, and let's give Kate a nice round of applause. There you go. Other questions? What else? I have a couple more questions, and I'll launch into my grand finale. Yes, what's your question?
How did you know which number was missing?
Oh, the missing number trick. That's a fun one. Like other magic tricks, it's a lot easier than it looks. Now, I know there were a couple of math people in the audience who figured it out. Let me remind you what happened. Right? We took this number here, I took this number, 3447, and everyone multiplied it by a 3-digit number, and they called out 6 of their 7 digits, and I told them what was missing, right? I took 3447 times a 3-digit number, and, okay, so what's going on? If you figured it out, if you think you figured it out, finish my sentence here. Oh, that trick wasn't so hard. He just took advantage of the magical property of the number 9. Good, I heard a few of you say 9. What does 9 have to do with it? All right, here. Let me write down all the multiples of 9 that I can fit on this board. And you tell me, what do the multiples of 9 have in common? What do they all have in common? They add up to 9. The digits add up to 9. 1 plus 8 is 9. 2 plus 7 is 9. 1 plus 2 plus 6 is 9. Oh, wait, I see an exception. There's 99. That adds up to 18. But that's okay, because 18 is a multiple of 9. So here's the deal. A number is a multiple of 9 if and only if, when you add the digits, you either get 9 or 18 or 27 or 36, they have to add to a multiple of 9. Now, I got lucky a few times actually on this board because like 7056, that adds up to what? 18. I could have chosen this number because it's a multiple of 9. 2304, that adds up to 9. I could have chosen that one. 2704, that adds up to 13. I couldn't use that one. But I got really lucky when the 4-digit number that you chose, 3447, added up to 18. So I was able to use that number. All right, so I took that number and I said multiply it by a 3-digit number. If you have a calculator, quickly take 3447, multiply it by a 3-digit number. You'll probably have a 7-digit answer. Who's got an answer? Raise their hand. I'll do this really quick. Right? So who's got an answer? Okay, you do. Quickly give me 6 of your 7 digits.
5, 8, 7, 4, 1, 1.
587411. Now, I don't know what her 7-digit number is. I still don't know it. But I do know this. Her 7-digit number has to be a multiple of 9. Because she started with a multiple of 9 and she multiplied by something. So what am I doing as she's calling out these 6 numbers? Adding them up, right? Doesn't matter what order the numbers are added up to, her 7-digit number has to add to a multiple of 9. So she calls out 6 of them. 5 plus 8 is 13, plus 7 is 20, 24, 25, 26. So what did she have to leave out to reach a multiple of 9? 1 in order to get 27. Did you leave out a 1? Yes. Let's give her a round of applause, right? Suppose the numbers that she called out added up to 20. Then I'd know that she left out the number 7 in order to reach 27. Okay, now here's a trick question. Suppose the 6 numbers she called out added up to 27, then what did she leave out? 0 or maybe 9. You don't know. You don't know if those numbers add up to 27 or if those numbers add up to 36. So what do you do in that situation? Yes. You guess. But as a magician, you can do it in such a way that it does not look like guessing. And I got really lucky here because I only had one person put me in that situation, and it was the very last person, right? And I said, having a little trouble with this one. Do me a favor, concentrate on that number. I'm getting a lot of nothing. You didn't leave out a 0, did you? She said, yes, I took my bow. If I said, you didn't leave out a 0, did you? She says, no. I said, I didn't think so. But it seemed like you were thinking of nothing, you know, a little math humor. So concentrate harder. I'm going to get it this time. And then I tell her that she left out the number 9. Either way, it looks like you got it right the first time. Thank you very much. Before I launch into my grand finale, I was given permission, and thank you again for this, to do a very short commercial. If you are interested in, because I've got hours and hours of stuff I'd love to share with you, I have created several video courses from a company called The Great Courses, the teaching company. Anybody here get The Great Courses? Wondria, the teaching company? They're great. I've had the pleasure of creating 6 different courses for them. The 6th one comes out in 3 months. I'm very excited about it. But here they are, very briefly. I have a course on the secrets of mental math. Everything I know about doing math in your head, addition, subtraction, multiplication, squaring, some mathematical magic tricks. Great fun. I have a course on the mathematics of games and puzzles, from cards to Sudoku, whether you want to use it for counting cards in blackjack or understanding how to solve a Rubik's Cube or any Sudoku, that's in here. I have a course on math and magic. It's about mathematical card tricks, number tricks, geometrix. Great fun, how to look like a psychic. I've got a course on, this is the hardest one, discrete mathematics. It's the math that underlies computer science and data science. It's what I've taught at Harvey Mudd for 35 years. It's a college level course. And then there's a middle school and high school level course on the joy of mathematics, everything from algebra to calculus. They sell these courses online for upwards of $200 each. I have them for $30 each, plus $10 for me to mail any number to you. So no matter how many you get, it's just a flat $10 for me to mail it to you. If you're interested, see me after the show. I take all forms of payment. That's the end of the commercial. Okay, thank you. All right, thank you. What I'd love to do now is something I indicated earlier in the show. I'm going to try to square a 5-digit number, but to make my job more interesting for you as well as for me, I'm going to do this last problem thinking out loud. So you can actually honestly hear what's going on in my mind while I do a calculation of this size. Let's create a 5-digit number. How about the fourth row here? 1, 2, 3, 4. If I get the first 5 of you, your last, each call out a single digit. That will be the 5-digit number that we'll use. Go ahead.
6.
6.
7.
7.
4.
4.
2,
2.
9.
9. 67,429 squared. Yeah. Let me explain to you how indeed I'm going to attempt this problem. I'm going to break the problem down into 3 parts. I'll do 67,000 squared plus 429 squared plus 67,000 times 429 times 2. Add all those numbers together and with any luck arrive at the answer. Now let me recap. Thank you. While I explain something else. As I do this last calculation, you will hear not just numbers, but occasional words enter the calculation. This is a phonetic code, a mnemonic device that I use to temporarily turn numbers into words. I don't do them for most of the mental math, but when the problems get really big like this, it's something I have to do to help my memory. One last instruction for my judges with calculators. Now, who has an answer? Raise your hand. A few of you, good. You should have a 10-digit number that begins with a 4, ends with a 1. In between, I don't know yet. There's a 50% chance that I'll make a mistake somewhere in the middle. If I do, don't tell me what the mistake is. Just say you're close or something, and I'll try and figure it out, which can be pretty entertaining in itself. If, however, I am right, whatever you do, don't keep it to yourselves. Make sure everybody knows that I got the answer right, because this is my big finish, okay? So, without any more stalling, and I have been a little, here we go. I'll start the problem in the middle with 429 times 67. Now, 429 is 430 minus 1. I'll take advantage of that. Now, I'm going to do 43 times 67. I get 2680 plus 201 is 2881. That's 28,810 minus 67 is 28,743. 28,743. I got to try that one more time. Just did I say 28 or 26? I'm going to try 26,820. Yes, it was 28,810 minus 67 is 28,743. Double that to get 57,486. 57,486 becomes Lucky Ravish. Lucky Ravish is 57,486. That seems right. I'll go on. Lucky Ravish. Okay. Next, I do 67 squared, which is 4489. So I can say 4 billion. Take the 489, add that to Lucky. 489 plus 57 is 546 million. Ravish, ravish. Okay, finally we do 429 squared. That's 400 times 458 plus 29 squared is 183,200 plus 841 is 184,041. 041 becomes sort. I take the 184, add that to ravish, oh boy, to get 670,041. Yes! Good! Thank you all very much. I hope you enjoyed the mathematics honors event. Thank you. Thank you, all of you. I'll see you in the lobby if you have any more questions. Thanks again. Thank you.